Hello, hi all. Today I'm going to discuss about very important concept about repartition and coalesce. Okay. So in Databricks or a Spark, when you are attending for any interview or when you are working in real time, so these two concepts are very important: repartition and coalesce. So repartition is nothing but usually the partitions, okay? The partitions means what? Okay. So you are dividing the data, okay? So example, what I mean to say here is, so you have 1,000 records, okay? Example, you have 1,000 records. So partition is nothing but what? We are dividing our data, okay? So you are dividing like some 250 records into one set and another 250 records into another set, another 250 records into another set. Okay, so like this way, you are going to split total 1,000 records into four different partitions. Okay, so instead of directly reading all the 1,000 data, so partitions, by creating the partitions, you can split the data and you can easily process. In real time, these partitions are very important to process your data very efficiently. So especially I told you, right, Databricks is designed for the handling the big data structures. Okay, like if you wanted to load multiple data, like a big volume of data like 1 TB, 2 TB, 3 TB, or GBs of gigabytes of data or petabytes of data. So the Databricks and Spark having the distributed mechanism, and as well as these partitions are applied. So based on partitions, your data get easily read and it will iterate the data in a quicker basis. Okay, so here now repartition is nothing but, so you can decrease or you can increase the partitions. What I mean to say here is, so let me rub this one. So example, you have given a condition that partition is equal to, okay, so I'm going to give some six partitions. So what it will do is, example, I wanted to create a partition, right? So first it will create one partition and then two, three, four, five, six. Six partitions it will create. Example, I wanted to decrease the partitions again to something like 4. Okay, what it will do is the decreasing order. It will go like 6, okay, and 5 and 4. So like that way, data get decreased in this manner. Okay, increase, decrease. Okay, so data going to increase and decrease order. The partitions get increased or decreased based on your partitions. Okay, so this is how the partitions will work. I'm representing increasing order and the decreasing order. Okay, partitions are used for the main thing is the performance perspective. Okay, and there are some drawbacks as well. The main drawback is so the full data shuffling will be there in repartition. Okay, so data shuffling is nothing but data movement, how the data is distributing for each node or for each partition. Okay, so especially if you are dealing with the large data, so the partitions need to be accordingly distributed your data. Okay, so if you have a full shuffling, so this will cause the performance issues. Okay, so this will cause you the performance issues to your data. So so that, so if you, whenever you are dealing with TBs of data, you always need to check while creating the repartition. So repartition, always choose for your based on your data. Don't go with like, if you have a large number of data set and before you are applying, you can check that. Okay, And Coalesce is completely a decreasing order. Okay, if you give as a 6 here, Coalesce of 6, okay, so what it will do, it will be in the decreasing order. 5, 4, 3, 2, 1. Okay, whatever you have given, so same partitions get decreased over here, and you cannot able to increase the partition. Even if you give 7 as a partition number, it won't increase. It will stretch for that actual. Okay, so let's quickly I will show you in a practical manner how this thing will work so that you will get more understanding. Let's go into the data bricks. Okay, so this is my data frame. I have created one file with order data set. I'm going to write my file into a Parquet file format. Okay, so this is my data frame dot repartition. If you type, you see here, there is a command called repartition. Click on repartition and you need to give the value. How many partitions you wanted to prepare for this one. Example, I wanted to give some 5 partitions. Okay, and dot write dot. So you need to give which kind of file it is. So it's a Parquet file format, right? Write the Parquet and so give the Parquet path. Okay, so I need to save this file in this path. Okay, okay, and single quotes, and I'm going to load it. Let's, and also we need to give one more command called mode. Okay, so the mode is nothing but, so it will be a overwrite mode. Whenever the data comes, I'm going to overwrite. Overwrite, it will always overwrite the data whenever the data comes. Okay, I'm going to give the file name as product underscore order. Okay, so this will create the partitions. If you see here, once you execute, the data get written into the partitions. So let's wait for the command to execute. Okay, so once it execute, let me refresh over here and you will be able to see one folder. You see, we have not created any folder, but if you observe, there is a folder created. And also if you see how many files are created, we have given 5 as a repartition value. Okay, so we have given 5 as a repartition, and you see here the size also equally distributed. Okay, example, so this file is having okay, so this is the one file. Okay, if you click and try to edit, anyhow you won't be able to understand this Parquet file, but let's see. Okay, so this is about my Parquet file and these are my records, my data. Okay, so this is how data get aligned in the partition. Now I wanted to decrease my partitions now. So I wanted to decrease to 2 partitions. Let's execute this. Again, once you try to do the repartition for with the 2, it is now currently in a decreasing. So let's observe here in this folder, you can see now only 2 partitions get created. You see, 2 partition with the size is 3.42 MB. 3.42 MB. Earlier, if you observe 1.15, like that way equally distributed, and similar way here also, the 2 files in a decreasing partition manner, you can see the values over here. Okay, so this is how the partitions get created over here. You can increase based on your data volume. Example, I wanted to increase again back to 10 partitions. So let's observe the data again here. If you see here now 3.42, right? So let's observe the data sizes after the data refresh. You see here, now all the files are splitted with different size. This file having this size, another file having 838, 838, and 36. So this is the way which the files are distributed, but these are not in a equal size. These partitions are not in a equal size. I told you there is one important thing, data shuffling. So data shuffling will happen here. So you have given 10 partitions. Now the data is not equally divided. So example, this file contains some 1,000 records, and this file contain only something like 2,000 records, 3,000 records, okay, and so on. Okay, so it is splitted like different record counts which it gives. Okay, so there is a data shuffling in the sense what? So the data, so first iteration when you run, so data will be changed. Example, you have 1,000 records in the file, and for the next partition it will change to 2,000. Okay, and another partition it may be again 500 records. Okay, so the partition won't maintain equal number of sizes or equal number of records in for each partition. So that's how a repartition will work. And also I wanted to show one thing. If you go over the Spark execution, click on the view. So, and I'm going to expand here little bit. So if you observe here, so the main functionality, okay, you see here shuffling read. Okay, the data shuffling, when it reads, there is a 13.0 MB data shuffling happened. Okay, writing there is no shuffling, but reading there is a shuffling. And you can check this stages as well, how the file got read into the system. Okay, you see here, now this is the correct, these are the step-by-step stages. Your output having, this is the shuffling, and same thing written, and similar way for each iteration, data shuffling will be there for read and write. Okay, so these many data shufflings happen in and out. Okay, so this is how you can check the data shuffling and the storage if you wanted to check. So these are all very important. I'm going to explain in another session how this will works. This is only for the repartitioning and coalesce. So only this concept I can cover. So now similar thing I'm going to do for a coalesce. Let's observe the coalesce as well, how the coalesce will work. Only thing you need to change here, coalesce, that's it. So coalesce of example, same thing, I'm giving some 7, coalesce of 7. Now let's execute it. So coalesce of 7, and similar thing we will observe the data loading process here. So let's observe here. In the data, you see here, you have given the partitions as 7, but actually it took the 4 partitions. Okay, only 4 partition it is equally divided, even if you create it as a coalesce of 7. Okay, because always this coalesce will be distributed, and also you can see the data sizes here, so it will be assigned in a proper manner. Okay, and the accurate whatever the values are there, all these files are equally distributed. Okay, and you see here, so this is the file name 62.1, 63.1, 64.1, 65.1. This is a sequence which created here. And now I'm trying to decrease this. Let me decrease this to 2 partitions. Let's try to do check this one. Now I'm trying to decrease it. Okay. So let's observe here. Okay. So now 2 is created, right? So now it's in the decreasing order. So as per the functionality, decreasing order, it will work perfectly. Okay. But now I'm going to increase the partitions again. Let me try to increase to 10 partitions. Okay. It won't move beyond that 4 partitions, whatever it created. Let's check this one. Even though if you give 10, it won't split to 10. You see here, it only set to 4 partition. The data got stretched over in the 4 files. It did not move. Even though you have given the 10 partitions, it did not move. Earlier, for repartition, if you increase 10 is creating 10, 20 like that. But here, when you try to increase it, it is still stretched up with the 4 partition. Once you create, you cannot increase. It will be in the decreasing order. Okay. So that is how this repartition and Coalesce will work. Okay. Hope this is clear. And also you can see the Spark cluster above one. If you see, you have 2 job clusters created, but if you see in Coalesce, you can see only 1 Spark cluster is created. Okay. So this is how it works in the real time. Okay. So real time also you can observe these stages. Okay. So that you will come to know how it executed. You see here, there is no data shuffling. Okay. But when we try to increase or decrease, so there are some data shuffle happened earlier. Okay. So this is how it works basically. Okay. Yeah. So this is how repartition and coalesce will work. Okay. Yeah. Thank you, team. Bye.